to this lecture video. In this video, I am going to explain problems on lasers and optical fibers, which comes under module number 3 of engineering physics prescribed by VTU. Now let us go to the problems. The first problem, find the number of modes of standing waves in the resonator cavity of length 1 meter in helium neon, temperature of laser operating at wavelength 632.8 nanometer. So the temperature of laser which is operating at wavelength 632.8 nanometer. So here the value of L is given as 1 meter and lambda is 632.8 nanometer. So we know that L is equal to n lambda by 2 and n is written as 2L by lambda. So here n stands for number of modes of standing waves. Therefore n can be written as 2 into L by lambda or 2 into 1 by 632.8 into 10 to the power of minus 9. So on simplification the number of modes will be 3.161 into 10 to the power of 6 modes. So L value is n lambda by 2 and the value of n is 2L by lambda. So the value of L is given as 1 meter and lambda is 632.8 nanometer. So substituting the values in the formula and on simplification the value of n is 3.161 into 10 to the power of 6 modes. So this is the number of modes calculated and this is what the solution for this problem. A fiber with an input power of 9 microwatt has a loss of 1.5 dB per kilometer. If the fiber is 300 meter long, calculate the output power. So input power is 9 microwatt, that is 9 into 10 to the power of minus 6 watts, and attenuation, that is alpha, is going to be 1.5 dB per kilometer and the length of the fiber is 3000 meter or 3 kilometers. So what is the value of output power, that is P naught. So we know the formula for alpha, that is equal to minus 10 by L logarithm of P naught by Pi. Therefore P naught can be written as Pi into 10 to the power of minus alpha L by 10. So substituting the value of alpha, Pi and L in the formula, then P naught will be written as 9 into 10 to the power of minus 6 into 10 to the power of minus 1.5 into 3 by 10. So the value of P naught is calculated as 3019 microwatts, that is 3019 into 10 to the power of minus 6 watts. So this is what the solution for the given problem. The numerical aperture of an optical fiber is 0.2 when surrounded by air. Determine the refractive index of its core given the refractive index of the cladding is 1.59. Also find the acceptance angle when the fiber is in water. The refractive index of water is given as 1.33. So here the given data is n0 into numerical aperture is equal to 0.2 and refractive index of cladding is 1.59 and refractive index of surrounding media n0 is equal to 1.33. So what is the refractive index of core, that is n1, and also theta naught value. So we have to calculate what is the cone acceptance angle theta naught. So numerical aperture is given by square root of n1 square minus n2 square by n0. So therefore n1 can be written as square root of n0 into na whole square plus n2 square. So substituting the values of n0 into na and also n2 in the formula, so it is nothing but square root of 0.2 square plus that is 1.59 square. So on simplification the value of n1, that is refractive index of core, is 1.603. Further we know that theta naught is equal to sine inverse of square root of n1 square minus n2 square by n0, that is equal to sine inverse of square root of 1.603, that is calculated value, square minus 1.59 square divided by 1.33. On simplification the value of theta naught is found to be 8.65 degree. So this is what the acceptance angle calculated for this problem. So the value of numerical aperture is calculated as 1.603 and the value of theta naught is calculated as 8.65 degree. The angle of acceptance of an optical fiber is 30 degree when kept in air. Find the angle of acceptance when it is in a medium of refract index 1.33. Here theta naught is 30 degrees and n0 is 4 by 3, that is 1.333, and n naught is 1 for air. And what is the value of theta naught? That is the angle of acceptance. So using the formula n0 sin theta naught is equal to n0, that is n0 sin theta 0 is equal to square root of n1 square minus n2 square, that is equal to a constant. Therefore we can write theta naught is equal to sin inverse of n0 sin theta naught divided by n0. So sin inverse of 1 into sin 30 by 1.333. So on simplification the value of theta naught is, that is theta naught dash, that is observed to be 22.03 degree. So here theta naught is given as 30 degree and theta naught dash, that is the angle of acceptance of the optical fiber, which is 30 degree when it is kept in air. Then when it is kept in a medium of refract index 1.33, then the value of theta naught becomes theta naught dash. So theta naught dash is observed to be 22.03 degrees. So this is what the solution for the given problem. Calculate the numerical aperture, V number and number of modes in an optical fiber of core diameter 50 micrometer. Core and cladding refractive indices are given as 1.41 and 1.4 at wavelength 820 nanometer. So N1 is 1.41, N2 is 1.4, lambda is 820 nanometer, and the thickness, the diameter of the core is 50 micrometer, and N0 is found to be 1 for air, that is the surrounding media. And then what is the numerical aperture, and then number of modes and V number. So numerical aperture is given by square root of n1 square minus n2 square divided by n0. So substitute the value of n1 and n2 here, that is square root of 1.41 square minus 1.4 square divided by 1. So numerical aperture will be calculated as 0.168. And then the value of V is given by pi d by lambda into numerical aperture. So substitute the value of d and lambda here and also numerical aperture calculated. Then on simplification the value of V is found to be 32.18. And the number of modes supported by the optical fiber is given by as V square by 2. So n is equal to V square by 2. So V is observed to be 32.18 square divided by 2. Then on simplification we will get it is 517.5 or it is approximately equal to 580. So number of modes supported by the optical fiber is 580 and V is found to be 32.18 and numerical aperture is found to be 0.168. This is what the solution for this problem. The refractive indices of core and cladding of a step index fiber are 1.45 and 1.40 respectively, and its core diameter is 45 micrometer. Calculate its refractive index, that is refractive, that is for calculate its relative refractive index difference, V number at wavelength 1000 nanometer, and also number of modes. So here we have to calculate relative refractive index, that is nothing but delta. Delta is given as n1 minus n2 by n1. And here the value of n1 is 1.45, n2 is 1.4 and lambda is 1000 nanometer and d is 45 micrometer. So delta is given as n1 minus n2 by n1, that is 1.45 minus 1.4 divided by 1.45, that is equal to 0.0345. And V is calculated as pi d by lambda into numerical aperture, that is square root of n1 square minus n2 square by n0. So substitute all the values and on simplification the value of V is found to be 53.34 and the value of N is number of modes. supported by the optical fiber, that is n is equal to v square by 2. So that is equal to 53.34 whole square by 2. That is observed to be 1423. So this is what the solution for the given problem. Thank you. And here is one more problem, that is find the number of modes of standing waves and their frequency separation in the resonance cavity of 1 meter length of helium neon operating at wavelength 632.8 nanometer. So here L is 1 meter and then lambda is 632.8 nanometer, and the value of L is written as n lambda by 2 and n is equal to 2L by lambda. So substitute the value of L and lambda here, and on simplification the value of n is 3.161 into 10 to the power of 6 modes. This is what the solution for this problem. And here is one more problem, that is a signal with input power 200 milliwatt loses 10% of its power after traveling a distance of 3000 meters. Find the attenuation coefficient of the fiber. So Pi is given as 200 milliwatts, and then P naught is 90% of Pi, that is 0.9 into 200 into 10 to the power minus 3 watts, and L is 3000 meter or 3 kilometer. So what is the value of alpha? That is attenuation coefficient. So we know that alpha is equal to minus 10 by L log of P naught by Pi, that is equal to minus 10 by 3 log of 0.9 into 200 into 10 to the power minus 3 divided by 200 into 10 to the power minus 3, and on simplification the value of alpha is found to be 0.1525 dB per kilometer. This is what the solution for the given problem. An optical fiber has refract index 1.5 and refract index of cladding is 3% less than that of core index. Calculate the numerical aperture, angle of acceptance and internal critical acceptance angle. So here N1 is 1.5, N2 is 97% of N1, that is 0.97 into 1.5, that is equal to 1.455, and then N0 is observed to be 1. And what is numerical aperture? And theta naught and theta c. So numerical aperture is given as square root of n1 square minus n2 square by n0, that is equal to square root of 1.5 square minus 1.455 square divided by 1. So that is equal to 0.365. And further sin theta naught is equal to numerical aperture, therefore sin theta is given, that is theta naught is given as sin inverse of numerical aperture, that is equal to sin inverse of 0.365. So theta naught value will be 21.41 degrees. Further, we know that sin theta c is equal to n2 by n1, therefore theta c is written as sin inverse of n2 by n1. So substitute the value of n2 and n1 here, then on simplification the value of theta c is found to be 75.93 degrees. So this is what the solution for this problem. Thank you.